Okay, so let's see if we can find the equation of a plane containing points 1, 2, 3, 4, 7, 12, and -1, -2, 0. Okay, so that's like, all right, here's 3 points, yeah? I'm going to pretend this thing's my plane, right? So I need to find the equation of the board given my 3 points. So just throw them on there however. Am I doing a good job of representing where these points fall in space? No, absolutely not. Do I need to do a good job?
No.
Probably not. Okay, so what do you need to find the equation of a plane?
Normal vector.
Yeah, you need a normal vector? Okay, so maybe if I looked at like these 2 vectors here. Okay, so how do you get those?
Cross product those 2 vectors.
Okay, so once I have those 2 vectors, right, I'll cross them to get the normal. You guys see that?
Vector? Displacement vector?
Yeah, you want the displacement vectors, right? Okay, so what's the displacement between 1, 2, 3 and -1, -2, 0?
-2, -4, -3.
-2, -4, -3. How'd you get that?
Subtracting the final point from the last point.
Perfect. Yeah, you do terminal minus initial. Awesome. So what do you get for the other vector?
3, 5, 9.
3, 5, 9. Cool. Now what?
Cross those.
Cross those, get the normal vector, right? I need something that's perpendicular to both of these. So, whoopsie, a cross product's the right thing. So, how do you calculate a cross product again? Calculate the determinant of
Create a vector. I don't know how to explain it.
Okay, so
IJK on
how
the
about
top.
IJK is your first row?
Yeah.
Your second row is
One of the vectors.
one of the vectors. Doesn't really matter which. So -2, -4, -3. And the other row is
Another vector.
the other displacement vector. So 3, 5, 9. Alright, then what?
Then calculate the determinants. So I'm going to make them into little 2x2 vectors.
Okay, so what's your I component?
It's going to be -4, -3, 5, 9. And that's the smaller vector.
Good. So the smaller matrix, right, is -4, -3, 5, 9.
And then we're going to subtract.
Then we need to subtract the J stuff, and the J stuff is going to be -2, -3, 3, 9. Good. And then we need to add the K stuff.
It's going to be -2, -4, 3, and 5.
-2, -4, 3, 5. Cool. Alright, so I'm going to get a vector that's got, what's your first coordinate?
-11, 9, and 10.
So that's -36 minus -15, right?
-11.
Damn arithmetic. Gets you every time. Alright, and then the middle one is negative of what?
18.
-18 minus -9
And that's
gives me
positive.
+9. And the last term is -10 minus -12
Just 2.
gives you 2. Okay, so what was this thing?
That's a little vector.
Yeah, so this was, the normal vector was the cross product of the 2 vectors that were in the plane. So my normal vector is this thing, right? So really, right-hand rule, that's the thing that sticks. Wait, in or out? Does it matter?
No.
No.
No, not at all. Does it stick in or out?
Doesn't matter, does it?
Wait,
No, it doesn't matter, but which way is it?
It's hitting out. Oh wait,
On-
we did
through
2
the
to
board.
3.
Yeah, on this picture, right, it should be in, but of course this picture isn't representative. So it's good that it doesn't matter because I actually don't know. Right, because I don't know which side the smaller angle's on. You guys see that? Yeah, whatever. Okay, what do I do with my normal vectors information here?
Dot product
Dot product it with,
A new vector created with an arbitrary
General
point
displacement,
or XYZ.
okay, general displacement vector, so XYZ minus,
Either one.
Any of those points.
yeah, any of these
Yeah.
points.
Yeah.
So,
1, 2, 3.
yeah, I'd probably do 1, 2, 3, because what the heck, right? So your displacement vector is going to be
X minus 1.
x minus 1, x minus 2, and, oops, x minus 2. Don't be nuts.
What?
Y minus 2,
And then a z minus 3.
and z minus 3. And am I done?
Dot product. When it's done, it's done.
When it's done, it's done. So I get negative 21x plus 21 plus 9y minus 18
Set it equal to 0.
plus 2z minus 6. That's what I wanted to hear, Donald.
And then simple.
What?
We set it equal to 0.
Yeah, this thing better be equal to 0, right? Why should that be equal to 0?
Because it means they're perpendicular.
Yeah, because I want that, right?
The normal vector needs to be
Yeah, so what I did was I took an arbitrary point up here, x, y, z, right? Wherever. Here's that vector. I want that displacement vector to be perpendicular to that vector that sticks straight out, right? So that's what I'm saying here, right? When I say the dot product of the displacement with the normal is 0, I'm saying the displacement is perpendicular. Cool? So you got this whole business equals 0. Combine some like terms and you're good. Or leave it like this and you're good. Cool?
So that's our plane.
That's your plan right here.